Well, hi, good morning. Thank you for joining me here in my shop, keeping me company while I work on this very complicated radio that we have in front of us. So, yesterday, rather than be in the shop here working, instead I spent most of my free time yesterday studying the schematic for this radio. Oh my gosh. It is a beast of a radio. What I've done here is I've colored up some of the lines, as you could imagine. I've colored. The red ones are B+, either running to plates or to screens. And the green, which is very hard to see, there's some green here, is the AVC control voltage that's being put through the radio, and the blue is the audio circuits past the volume control. So there's the volume control over there, and there's the preamp tube, and then the final output tube there. What did I learn from this? From doing this? Well, number one, this is a complicated radio with circuits in it that I don't know if I'll ever be able to fathom what they're doing. B, the diagram is very large. They've got bundles of lines running all over the place in this schematic. Bundles and bundles of lines. It's complicated situations like this where the lines are all turning corners, and sorting your way through something like this is, for me, virtually impossible. It's loaded with these switches which drive me nuts here, trying to determine how a signal might go through all these switches. There's another whole batch of them here and here. There's one there. They're everywhere. So I think, part of the lesson from looking at this is this particular radio I'm probably never going to understand fully, if I ever do understand fully how a radio operates. So it's going to be something more like looking at it with a magnifying glass, or just study a small area. And it's very difficult because the small area has lines coming out to all these other areas. And yeah. So anyway, rather than continue complaining, I will tell you what I did discover. If you study this AVC line, you eventually come across, and where did it go? A capacitor that's a 0.1. Where'd it go? Somewhere in here is a capacitor for 0.1. I wanted to find it in the radio, and my gosh, I've lost it on the schematic already. Well, I'm gonna look this. I'm gonna find it. There's a 0.1 right there, but it's not on the line I'm interested in. Or is it? Yeah. So this is how it goes with this schematic. Clearly hand drawn, done without a drafting machine. So not on, whoever drew this didn't do it on a drafting table. With the drafting machine that keeps your angles perfect. He did it with a ruler and wow. Anyway, stop complaining about that. Okay, so somehow the 0.1 has disappeared, or it's moved to another location, and everything I thought I was going to do today has gone just down the drain. I think what happened here, maybe I misinterpreted the lines right in here, and my eye caught the 0.1, and I was all happy. I didn't look too much further. Well, I'm going to study this while I drink a little bit of coffee and try to figure out. I didn't really say what I think is going on here. The motorboating effect, I believe, has to do with the AVC delay. So that's why you're getting a pop, pop, pop. There's a delay in there, and that's because of the AVC capacitor and its effect on the throughput through the radio. I don't know how better to explain it. And in fact, that's not even an explanation. That's just a pile of confusion you just heard come out of me. But I think it really indicates that the trouble is in the AVC system, and somewhere there should be a fairly large capacitor that kind of controls the AVC. Right, I was going to go drink coffee and look at this. I will stop talking. I ended up drinking orange juice, not coffee, so don't know how this is going to go. I cannot find any significant capacitor on the AVC line, that would make me think that's the guy to go after. I mean, there's one sitting here, 0.01, and there's one way up here, a 0.01. Probably more in here somewhere for all I know. I probably haven't found them all. They just, yeah. So I think I need more information. I'd like to know a little more about what's going on with the radio, why it's making this pulse, and in the course of doing that, and looking at the schematic again, I've noticed a couple things about how they've done this. It may be hard to see on the camera, but can you see that these two switch wafers have a dotted line coming together to a dotted line running along here, and then it picks up two more, dotted line, two more, dotted line, two more, dotted line, all the way to this information here. It starts talking about sidebands and the position of the sideband switch. And that's what this is. This is the sideband switch. All this. Holy smokes. That's a lot of switching to kick in single sideband mode. Wow. Anyway, the point is how the drafting is done. And so it's the same thing was done up here. There's two switches here, and they're joined with a dotted line, and it runs along here, joining, that ends up in this data here, which talks about whether you're in AM position. Wait a minute, it's the bandwidth switch here. So again, look at all the switching going on. Wow, I almost get the impression that the Hammarlund people said, "Okay, Mr. Engineer, you're really good. Make us the best radio you can come up with, and we're gonna sell it." And to ham radio operators, this is a ham radio, quality radio. I don't think it was in military service or anything other than ham use, I believe. And this is what he came up with. And rather than, I don't know how to explain it, a multi-band radio utilizing the exactly same circuit over and over in the different bands, except for small variations, he's made huge variations in the band circuitry using all these switches. So as you switch from, this isn't even the band switch. Tim, you're not making a lot of sense. You see, that's what happens. It's orange juice and not coffee. I should really stop and go get some coffee. But I'll tell you my idea anyway. Forget all that nonsense I was just talking about. My idea is to take a look at the signal running through the IF. The IF here has two different frequencies. So this first part, first IF, I guess we can call it, is at 455, like many radios. And then it goes through another converter tube and converts it down to 60 kilocycles. And then it runs through these, at that intermediate frequency, it runs through these tubes here. So that's quite an IF chain there. It's really starting, well, here's the first converter, and you've got transformer, next converter, transformer. Wow, that's a lot. That's an awful lot. And the fact that it's using two different conversion frequencies means the radio's designed to combat the problem with image frequencies interfering with reception at higher frequency ranges, or on the highest band. You can start having image problems. But so that's what this is all about. It's all about getting rid of that. So it's quite the radio. The way I want to try to sniff out the IF and see what's going on in it is using just a pickup coil and my SDR radio, and I'll just tune it to the IF frequency, either this one or that one, and we'll see what we can see on the on it. What I'm anticipating is we'll see some signal in the IF get stronger and go pop, 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 like this, or maybe the other way around, pop, 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 something like that's going on. I suspect there's an oscillation in the IF. An oscillation we can't hear, and there's no apparent effect from it, except it's triggering at the detector. It's triggering a AVC voltage. That's a pile of baloney, isn't it? Well, that's the biggest pile of baloney you ever heard. But let's find out. I'm gonna sniff around. We'll see what's going on. Okay, so I did find the manual, the service manual for this radio. It's about a 50-pager, and I've just been going through it really the first time, just coming down looking for a tube layout diagram. I found this diagram, and I thought, of numerous places you could stop and study. Here's one. This is worth looking at. So the other thing I've learned just from glancing at the service manual here is that this is a triple conversion radio, not a dual conversion. So wow, engineers really went wild on this thing. So if we just look this over, what interesting thing can we find out? So I see 2 crystal oscillators on it. 3035 crystal filter, 3035 crystal oscillator. Well, that's all really curious to me, exactly what's going on there, but the crystals are doing 2 different purposes at the same frequency. Huh. Okay, I don't understand, but there we are. Then after that, there's something called a 455 kilocycle gate. I don't know. Sometimes a signal goes through that 6BA6 there under the gate word, or other times it's going through the mixer and the other conversion. I don't know. This certainly explains why there's so many switches in this radio. So now we're at 455. We go through an amplifier. There's a slot filter there, plus and minus 5 kilocycles. So I had noticed that the radio's audio response is very muffled. There's not much treble in it, and it was suggested to me by one of you that maybe the slot filter adjustment may have corrected that. I don't know, because the slot filter, and my understanding of a slot filter is that it's knocking something out. You're removing something with it. You're not able to add treble. If anything, you would knock it even lower. Second converter, and now we're at 395 kilocycles. Really? And then there's the vernier tuning hooked up to that. 395 kilocycle oscillator because of the 455. That's 60 kilocycles between the two of them, and so you can derive a 60 kilocycle IF frequency, carry on through more 6BA6s, and then you get to AVC AM detector. Down below it is the product detector, but just showing the tube, of course, the vacuum tube that's involved. And then BFO S meter amp, 1287, and then we have a noise limiter, and then we're out 2 tubes to the speaker. Look down at the power supply. They're just showing a rectifier. What's that mean? Silicon rectifier in A series. Oh, I don't have an A. I have a 180, not the 180A. So I have a 5U4. It's a great big tube in the back of the radio. Okay, did this really help? I don't think it helped too much. I'm going to continue looking through the manual here. Oh, wait a minute. Yeah, 180 and 180A. The A being this. This is a 180XE, 180AX. So they've included an X in here. Okay, so I'm going to go through the manual, try to find the tube locations, and then get ready to sort of sniff out the IFs. All 3 of them. Oh my gosh. Holy smokes. Okay. I'm overwhelmed. Okay, this explains things a little more. If you look at this, you have the S equals signal frequency received. So that S represents the signal coming in. These are the different bands over here. The first oscillator derives a 455 signal, which goes through the first IF at 455. But you see these two bands here, the highest bands, the first conversion is done to 3 megahertz. If we go back to this one, then it just runs along through some stages. And then we have another oscillator here running at 395, and you mix that with 455, you get a 60. Then you carry on with a 60 through the last part of the radio. So here, the first conversion is done at a higher frequency. And then using this as the local oscillator, it's converted down to 455, and then converted further to 60. So we get two stages in the lower 4 bands and 3 stages in the 2 upper bands. Wow, even here, even in the broadcast band, you've got 2 different IF stages. Wow. Okay, quite the radio. Onward. Never know what you're going to find here. Example of the slot frequency. So here you see the slot filter, and if you turn the adjustment, you move the slot filter around. So if you're picking up something ugly, say here, something's causing a heterodyne, you just move the slot filter over and kind of knock it out. Okay, I'm going to carry on. Still just looking for a tube diagram, tube placement diagram. Okay, I think I've got what I need. I've got a tube layout chart. Got this frequency table, help me understand what's going on. Got this coil. What I plan to do, I don't know how well this is going to work, is identify a key tube in here, like an IF amplifier tube. Pull the cover off, put this around the tube, and then hook this up to my SDR antenna. We'll see what kind of signals are around that tube. Then work the band, change, switch, see what's happening. And meanwhile, watching for this pulsing thing that's going on in the radio. I'm sure we're going to see an effect in the IF. I don't know. So a big theme in what I'm doing. I never really mentioned this, but a big theme is me having fun with these radios. So even if this is a stupid thing to do, it's kind of fun. So that's why I'm going to do it. Being stupid, hey, I'm a human being. That's kind of what we do much of the time. Is be stupid. Okay, and I think I need to feed in a signal from a signal generator. I'll use this one here. And so we have a known signal we're picking up. We tune it in, then the local oscillator is going to mix with it and produce the IF frequency that I need to track. So we can do this on all the different bands. Probably we'll start with the broadcast band and go from there. Okay, I get all this set up and ready to go. Okay, why don't we turn on the radio and get it warming up here. How do you turn this guy on again? We turn him on with this control here. Okay, so it's on, and away we go. Okay, so I got the dim bulbs in, so it's very, very low voltage to start off with, but there's no problem here. Okay, and we're cooking with gas. How much gas? 117 volts of gas. Pretty complicated warming up thing going on here. Okay, do you still have the speaker connected? I didn't check. Yes, I do. Okay. There we go. Ooh, this is why I was scared to operate this radio before. Not so scared in here. two things going on there. Now it's become that consistent. So I think it's AVC. Fooling around with the AVC should have a big effect on this. AVC off, different speeds. It's having no effect. So maybe I'm way off base on that. So there was a suggestion made that really what I'm hearing is a capacitor breaking down. So it's charging up and then shorting out and charging up and shorting out. It just seems a little too consistent for me. It's not messy enough. But I don't know. It could be happening inside a tube, even, this kind of thing. So let's carry on with the desired experiment. Okay, so what I'm going to do is I want to pick up the signal to start off with late in the radio. So we're going to pick it up way down here, late in the radio. So here we have some kind of detector going on here. I don't want to be there. Go ahead of it. 60 kilocycle IF amp V7. That's the guy there. We'll sniff this tube out and see what's going on inside it. No matter what band I have it switched to, 60 cycles, 60 kilohertz should be going through this tube. My SDR will tune down to 10 kilohertz supposedly. 10, you can hear 10 kilohertz, for crying out loud. So we'll go here. Tube 7. Tube 7 is located there. And about this way. Tube 7 is here. You know, this noise could even be just from a tube not seated well inside its socket. Let's turn it up again. Okay, so this is number 7. Let's just pull it straight up. I'm just trying to pull the cover off. There we go. I don't know what to make of the differences. Okay, so we're going to put this coil here now. Try anyway. A little tighter than I expected. That's going to be good enough. I'm trusting these cans are shielding the signals in the coils here away, and all we're going to really pick up is what's happening with this tube, but who knows for sure. Okay, let me turn it down. Now, I have to get the SDR happening here, so I'll just take a minute. Okay, now recognizing that this is all experimental, what I'm doing here, I don't really know what to expect. 60 kilohertz is down here where I've put the red tuning line, way down here. So we're going to zoom in on that a little bit. Actually, quite a bit. So at 60 kilohertz, we see nothing special in here at all, and that's because I think the radio's not tuning anything in. So I'm going to feed in a signal. I've got it set up for 1 megahertz. I've got the radio tuned to 1 megahertz. Why didn't we hear anything? The signal was too low maybe, or not tuned right on. Okay, so I'm tuning the radio up, and now I'm going to tune the signal generator as soon as I get over there. Okay, we'll see what if we hit the mark. So I'm just watching right around the red line on the SDR there to see if there's a pop-up. And nothing happening. What's going on here? Tuning far enough. Back and forth. Okay, I'm going to jack up the signal output. Oh, I know what the problem is. The problem is I don't have the... Okay, hang on. The problem is I don't have the signal generator actually connected to the radio. That's not going to work. Okay, so now I'm connecting the signal generator. What happened to it? Okay, signal generator connected. Radio is tuned to 1 megahertz. I'm double checking. Signal generator right around 1. A low strength. Let's see what happens here. Do we hit anything? We should hear it. There it comes. You saw it. There it is. Okay. Now I'm going to expand this even more. Okay. I'm going to increase the output of the signal generator. I am going to tune the radio itself. I go back and forth fairly quickly. I'm going to stop with the dial set right on 1,000,000. And the frequency generator set to 1,000,000. It disappeared, didn't it? Yeah. Lots of weird stuff going on there. Okay, I'm going to turn down the volume. I'm going to turn up the signal generator. This would be a very strong signal fed in the back of the radio now. Maybe even overloading it. It's possible. Let me check calibration on my signal generator. Okay, so we're dumping into the back of this 10,000 microvolts, which is a pretty strong signal. And the RF is up full. Let's just knock the RF control down and back up. Lots of things there to see and talk about, but let's not. Okay. I was kind of hoping the static would become suppressed and we'd hear the audio much better, but we don't. I'm going to switch over to CW from AM. Oh, well, that's a huge difference. Wow. Okay, I'm on the CW SSB or single sideband setting. I'll turn up the volume. Is it? That's got to be the pop there, just very, very slow now. Is that because I turned the volume up? Let me turn it up higher. Same speed? Yeah, same pop speed. Well, I don't know what I'm gathering from this. Let us try the antenna adjustment for some reason. So I'm in single sideband setting here, so I'm going to flip it to, it's on both, so I'm going to flip it to upper, and then flip it to lower, upper, and both. I'm going to change the modulation frequency from 1000 to 400. Okay, so now that clarifies a little bit. Let's go back to 1000. So on the SDR here, so that's the central frequency, and these are the sidebands. These should be 1000 cycles out from here because we have 1000 cycle signal, 1000 hertz signal, and they are. And if I switch to 400, the sidebands will close in. Now the sidebands are 400 out. But you can see some 800 here, and this is probably a part of it too. So none of this is helping me much, to be honest with you. We'll go back up to 1000. So this popping occurs on all bands. Now I can switch from band to band to band. The 60 cycles is still here on the display. I have to change the frequency I'm feeding into the antenna though to match. But let's try it. So right now we're down in the broadcast band. I'm going to go up one step. Now we're at, where'd the popping go? Where'd the pop go? Let's go back. Does it seem quieter? Not on the display. Here in the shop seems quieter. Oh, there's the pop again. It seems, I turned it up and the pop started. Turn it back down. Well, this pop is in the audio circuits, maybe. Let's turn it back up. I'm turning it down so you can't hear the pop. Let me turn it down a little bit. I'm turning it down progressively here. I think I just turned the volume down and the pop went away because the volume's gone. I don't think that's... Well, I could do it with the RF gain too. Try that. Oh my gosh, well that makes a huge difference. That's minimal RF. You know, if this radio had like 20 wax capacitors, I'd start going after them, but it doesn't. And I'm not going to start changing all the ceramic capacitors in here. It doesn't make any sense. I've got to identify the cause of this pop. Now, there's nothing apparent in the signal. So what if I just kill the signal that's coming in? We still get the pop. Why did I even need the signal there? Because I just wanted to see it. Let's go through each band here, just see what happens, since I have this set up. So right now I'm going to flip this to the next band. It's the upper end of the broadcast band, and the frequency we're around now is 2. So what's happening here is my signal generator is set to 1,000,000 and I'm tuning the radio at 2,000,000. It's picking up a harmonic out of the... That's okay, that's good enough. Pop is still going. We're going up another band. This is 2 to 4 megahertz. So if I find 4, we should hear another... We don't. I was thinking we would hear the another harmonic, but we don't. So what I'm going to do is I'm going to put the signal generator up to 4, where the radio is tuned. Here we are. We're at 4. Very sharp tuning. You see the pace of the pop increased there slightly. Okay, tuning the radio. I have it on single sideband, so I'm going to turn it off single sideband. That does the trick. That's RF gain. Is there other things I'm fooling with? Nothing's doing too much. Okay, so we're going to go to the next band. This is 4 to 7. So we can tune in, nice round number. Whoops, wrong dial. We want to tune in, let's say 7 megahertz. Okay, I'm going to dial up 7 megahertz on the signal generator. Here we are. Wow, it sounds like something radioactive. Why are there two things there on the SDR? Why two? What would that be from? We're set to AM, and I'm just sending out a modulated AM signal, but there's two things there. Could be alignment issues. That's flipping over to CW. Just again, it's still there, it's just slower and weaker. And back to AM. Okay, just for fun. We, oh, what band am I on here? Yeah, 4. Now we'll go to the next band. This introduces more conversion. And we go up to 7 to 15 megahertz band. Okay, now we're dialed in at, I'm going to dial it in at 14. Yeah, just like that. There's the harmonic from my signal generator. What's happening there? Huh. Okay, volume. So that's interesting. I turned the volume down, you could hear the modulation. Or is that modulation? Is that modulation? Yeah, it is. Well, I got a powerful signal here. That's probably what's going on. Too strong a signal being fed into the radio. Maybe causing some overload or something. Is that why we had two things there? We don't have anything there. I'm using the band spread now because the main tuning is so sharp. Even the band spread is tricky. But there's only one peak there. Let me jack up the output here. Whoop! Change frequency at the same time. So my signal generator is not the greatest here. Let's put it back. So I was trying to increase the output and the frequency drifted at the same time. This is the one to use here. Okay, so we'll jack it up this way and then turn it down. I don't know what's going on. All kinds of stuff going on here. Okay, we're going to the next band up. Next band up on the radio. 15 to 30 megahertz now. The radio dial is set to, let's go down to, what was that? I'm tuning something in here. Something strong at exactly 26. 26 megahertz. Why would there be something there? Signal generator is running at 7,000. It would be 28. Okay, I'm going to move the signal generator and find out if that's it. Oh, it's not. I'm moving the signal generator around. Ho ho. Ho ho ho. What's this oscillation doing here? 60. So there's something in the IF. Let's turn the volume up. You can't hear it over the nonsense here. Let's flip this to single sideband. Reduce the popping a lot. Got the volume up full. Now you can see the pop has an effect on the SDR. You can see it. You can also see that there's some kind of frequency involved in the waterfall display, but I don't know how to interpret that exactly. What are we learning here? Not much, but nothing specific is coming through. Antenna adjustment for fun. For some reason it's moving that back and forth a little bit. Now it's not. Moving the frequency back. I don't know what. what's going on there. AVC, slow, it was off. Slow, medium, fast, makes no difference, so it's not an AVC issue. Is it nothing more than audio? So what I'd have to do is extract a tube here from the radio that will stop the signal from reaching the audio circuits, and then see what's left. Why would there be this rather hefty signal sitting here? Tune the radio. Tune the radio. Okay, so it's something the radio's picking up. 26. Okay. I'm gonna switch cameras here. Okay. So we're tuned to 26 megahertz. What could possibly be there? 26 megahertz. Let's see if we can find something. I don't know that it's exactly 26 megahertz. Yeah, wait a minute. I don't know that this is really picking up 26. This could be picking up, 25.95 or something. So we can find out with the signal generator. So we're going to put this up. And we're going to go up to 26 megahertz. Okay, we need the SDR showing again. Okay, so I'm going to tune the signal generator until we see it there. Oh. There it is. So that's us matching this frequency. It's 25.82. 25.82. Okay, let's go back to the camera. $25.82. That's my signal generator we're hearing now. So now I'm on the frequency. I don't know. What's that? Is that something? This has sideband, does it not? It does not have a sideband. So, okay. There's something there. There's definitely something there. What would it be? Is it? Who knows? Who knows what it is? Well, and this isn't again Bayesian logic. A lot of things I do in here, and I get some kind of result, and I see it on the meter, I hear it coming out of the speaker, whatever it might be, and I don't really say, but I sort of gauge these things quickly. And should I pay attention? Should I not? Is it valid? Is it not? I'm weighing this stuff all up. That's what people do. We're really good at it, in fact. We're really good at environments with poor information, trying to sort out what to do. That's basically what life is all about for human beings. It's trying to get through low information situations, insufficient information, incorrect information, trying to find your way through it to do the right thing, whatever it might be. So that's kind of what, this is just a microcosm of that experience, basic human experience here. And part of the human experience for me is massive confusion. Yes, massive confusion here. Okay, I'm kind of losing it. I'm losing it. So we were listening to the sound, came across something here, got curious about it, still don't know what to think. Moving on. Let's do this. So signal generator. So I'll take off the antenna completely from the radio. No antenna. It's all by its lonesome now. We will again look at this. Huge difference here. Not so much here. So this guy's having an effect. This guy a little bit. This guy's having a big effect. Vernier tuning. Nothing too dramatic. BFO is not even switched on. Slot filter could be doing something we wouldn't even notice. Okay, well, the end of this little experiment is I really don't know what's going on. Let's try the isolating the audio technique. We'll just leave the audio circuits going. So we would want to pull out, I would say pull out the tube. Oh, this guy's a two-parter. Pull him out. We're pulling something else out too. Could pull this guy out. Could pull out V7, the same one I'm testing. That'll cut off all the radio to here. All we'll have is this. That's not bad. Let's do that. So I'm going to pull that tube out. I need a glove. Where? So again, I reorganized my shop a bit, so I'm really clueless as to where things are. So we'll try to pull it out with this. It shouldn't be too hot. Turn it down. The tube is out. How do you like that, eh? That tells you a lot. That tells a lot. Let's see if I can stick that tube back in. Leave it out. Leave the tube out. Pull out another tube. The other tube, pull out. I'm assuming that now the radio has no influence in the audio part of it. That all this is cut off, but I don't know that for sure. Who knows what. So, isn't this a radio control? It's not in the audio circuits. And the mystery continues. Pull out more tubes till it stops. Then throw that tube away. Another tube to pull out would be this, the first audio tube and delayed AVC tube. This is V16. V16 is where are you? You've hidden it away. 15, 14, 17. It's right in front of me and I can't see it. Well, that's the problem. There's no V16. Look at this. V18. V18. Well, how can that be? This is first AF, delayed AVC. This one is the gate. The gate. There's the gate. Oh, it says 18. Well, it must be. No, it's not half a tube. What are they doing here? 6BA6. That's just a single tube. V18. Oh, this is V16. V18, V18. This is supposed to be 16 here. I think that's probably the case. First AF, delayed AVC, 6AV6. 6AV6, V16, first audio delayed. It's got to be that. It's got to be this one. Everywhere you go. Stuff is, see, you know, this is a perfect example of Bayesian logic. Is it? I don't know. Is there any logic? Is there any logic involved at all? So let's pull this one out. So we make a mistake here. We look at it this way, and it's this one over here. This one over here. Okay, so we pull that guy out, and there's just nothing going to the output tube. Period. Volume's down. Oh, these are tricky to get out of here without hurting yourself. I gotta do a little prying here. Scare the heck out of me. Yeah, okay, let's do this with the radio off. So how hot is this? Ah, it's not that hot anyway. There we go. Now the tube might be hotter. 6AV6. Yeah, that's what it is. Okay, leave that guy there. We'll turn the set back on. You could ask yourself, is there any tube here that if you pulled it out it would be dangerous for the radio? I don't think this radio, but there are radios, these wonderful transatlantic style of radio with a kind of a brownish or red leather cabinet, portable radio with little 1-volt tubes. Don't pull those tubes out with it operating. Okay. What do we got? What do we got? Well, we don't get anything. Well, there's the problem. You pulled this tube out, problem gone. Fantastic. Okay, I think I'm going to leave it there for today. So we're going to turn this guy off. Yeah, let's see. Does this burn my hands? No, it's not that hot. It really isn't very hot at all. Let me just put the thing back together here so it's in its normal condition. Likewise with this tube. I'm doing this right now so I don't forget. You come here tomorrow and start operating the radio with tubes out and not remember that I did that. Here we are. Okay. That's it. I got a busy day ahead of me. That's as far as I can get today. I didn't really get anywhere. Had some fun though. That's good. Okay, well, thanks a lot for watching. I'm sorry this is a runaround, but at the early stages of any complicated radio repair, there's a huge learning curve. You can't even see the end of it when you start. You don't even know where you are on the curve. That's the situation here. So thanks a lot for watching, and I'll see you tomorrow.